Hello, Sir Parts online subscribers. Welcome to Sir Parts I Teach. Our topic is Learn Machine Learning in W3 schools. Yeah, guys, thank you, everyone. Please do not forget to subscribe and ring the bell so that you could get the latest videos of Sir Parts online. And also make some comments out there so that we could know what are you learning. And let's start. Okay, so our last topic is all about this one, scatter plot, and today we are going to have linear regression. Okay, machine learning linear regression. Regression. The term regression is used when you try to find the relationship between variables. In machine learning and in statistical modeling, that relationship is used to predict the outcome of future events. Okay, linear regression. Linear regression uses the relationship between the data points to draw a straight line through all of them. The line can be used to predict the future values. So that's the line, no? And machine learning, predicting the future is very important. If you can predict you will become successful in the future, that is possible. No? How does it work? Python has methods for finding a relationship between data points and to draw a line of linear regression. We will show you how to use these methods instead of going through the mathematical formula. And in the example below, the x-axis represents age. You have the x equals 5, 7, 8, 7, 2, 17, 2, 9. And y-axis represents the speed. Now, this is all about the age and the speed of the cars, guys, in our previous example. So we have registered the age and the speed of 13 cars as they were passing a toll booth. Let us see if the data we collected could be used in a linear regression. So we use a scatter plot for that. So we have this. Okay. So we have this. We use a scatter. The scatter. Let's try to click the example in order to see the code and the output. By the way, if you're going to click this, guys, the value would be the same or not? The same. Yes, you're correct. It's the same because we have this data here, the x and the y data. This is not similar with the generating of random numbers. Okay, so if you don't believe, let's try to click run. And what we are going to see is similar diagram scatter plot that we have in the previous one. Okay, let's move. Okay, so we're going to import SciPy for this particular activity in order to draw the line of a linear regression. That one, as you can see the line, that line. That is because of our code. So let's try to click the run example so that we could see the code. Okay, so here we have import sys, import matplotlib, matplotlib that use AGG. These are similar codes that we used before. Import matplotlib, .pyplot as PLT, from SciPy import stats. So we have the x and the y data. We already have this one. And we have the slope, comma, intercept, comma, r, comma, p, standard error equals stats that lingris xy. So this is now these are the something the new code that we have here in our program, and we define a my function x where it returned the slope multiplied by x and included by the intercept. As if I remember it well, this formula is y equals mx plus plus b. Y equals mx plus b if I'm not mistaken. Y, the m stands for slope, the x and the b is the intercept. And you have there the model, my model equals list, my map, my function. And you produce the scatter by this, and you can make the line through the x my model function, and the last two lines are in order for you to draw in our program. These are necessary. Okay, so this is linear regression. So okay, these are the explanations. Import the modules you need. We have that. You can learn the model. Okay, the SciPy. Okay, then we create arrays. That one we create the arrays, the x and the y, the age and the speed. And after that, we execute a method that returns some important key values of linear regression. Then we create a function that uses slope, which is slope, and the intercept values. And then we run each value of the x array through the function. This will result in a new array with new values of the y-axis. So draw the original scatter plot using this one, PLT scatter. And this is now the PLT.plotx, my model. We now draw our linear regression. And by PLT.show, we display our diagram. Okay, R4 relationship. It is important to know how the relationship between the values of the x-axis and the value of the y-axis is. If there are no relationship, the linear regression cannot be used to predict anything. It can't predict anything if it has a relationship. So this relationship, it is called the coefficient of correlation, is called R. The R value ranges from -1 to 1, where 0 means no relationship and 1 and -1 means 100% related. Python, the sci-fi module, will compute the value for you. And you have to do is fit it with the x and y values. So here is a sample code. Let's try it. Okay. So from SciPy, import stats, x and y, these are our arrays for our age and the arrays of our speed of cars. And we compute for our R, slope, comma, intercept, comma, R, comma, pa, standard error, stats, that lingers of X and Y, and we print R. And as you can see, we have negative 0.758591524376155. That's a negative number, and that's negative 0.75. It shows, the result shows that there is a relationship. Not perfect, not perfect -1, but it indicates that we could use linear regression in future predictions. So that we can predict future values. Okay, predict future values. Now we can use the information we have gathered to predict future values. Sample, let us try to predict the speed of a 10-year-old car. To do so, we need the same myfunc function from the example above. If myfunc x return slope times x plus intercept. So, predict the speed of a 10-year-old car. So, here we have this code from SciPy import stats, x and y. That is our, yeah, that's our data, the age and the speed of the cars. And we have the slope, intercept, RP, standard error equals stats that increase xy. So we have the result for that. And we create a my function function. We define a function, my function x returns slope times x plus intercept. Then we speed my function. We use the speed of 10, and it is going to print the speed of the car. Okay, so let's try. So that is the speed of the car for 10, 85.59. Why is that? It's because of the prediction of this particular. Let's say, for example, let's try to have it 20. So what is the speed of the car for 20? Okay, for 20, let's run. If the car is 20 years old, that is because we have the slope, no? It becomes 28. So if the car is around 40 years old, as you can see, guys, as it ages, the speed of the car slow, no? That's 40 years old, and the speed is now 33. Let's say, let's have it double. Let's have 80 after 8 years of the car. What would be the speed of the car? The speed of the car is -36. That is impossible, guys. That's very impossible because the speed. How could a negative speed be? Okay. Anyway, so that's it, guys. And Yeah, you can use a prediction for that. The example, predict the speed at 85.6. That could read from diagram. So bad fit. What is bad fit? Okay, let us create an example where linear regression would not be the best method to predict future values. So bad fit, no. So these values for the x and y axis should result in a very bad fit for linear regression. So we have here x is 89, 43, 36. These are the speed. I don't know what are these. What are these values? The values for x is that, and the values of y is also that. And this is the result. Yeah, that's it. That's the result. You can see the line. Let's try to run the example. Okay, so you can see the line. That's no relationship. No relationship. There's no relationship, guys. Um, the line is not going up or going down. It's in the middle. By the way, this is to create the line. If you can remember, you have this one, no? To create this particular code, can create your line, your line here, and that particular line shows that there is no relationship, and that is bad fit, and that is bad fit. And to compute for the R, uh, okay, let's try to click this one. Okay, the the R is 0.013, so it's near to zero, and that's a bad fit. That's no relationship. You can say that that's a very bad relationship. Also, this is not suitable for linear regression. Why? Because um the number is near to zero. Okay, so that's it, guys. Thank you very much for watching. I hope you learned something. And our next video is all about polynomial regression. Please do not forget to like and subscribe and ring the bell so that you could get the latest videos of Sir Parts Online. Bye, everyone. Always remember, learning is lifetime. Bye.